Hey guys, so today this is what we're going to try and do. Let me restart it, show you. This is what we will get at the end of this, right? All right, so let me go to the whiteboard and let me explain you how it works. Let me get a marker. Okay, awesome. So basically there will be branches, if you want, that goes out in some direction. And those branches will have like steps, right? We'll have other branches, right? So we'll try to do like a recursive thing. On one given branches will have its next branch, and so on and so forth. So basically, if we have our canvas here, right? So we're going to create one branch. So, and we're going to pass it a position, right? So x, y. And that first branch position will always be the middle of the canvas, right? So width divided by 2 and height divided by 2. It'll also have an angle in radian. So that angle would be, so basically this would be 0, this would be half pi, pi plus half pi, and then going back to 0 or to pi. So those are the main components of one branch, and it will need to create its next branch. So it's, let me remove this. All right. So its next branch, let me make sure you can see. Yep. Okay. So its next branch will be equal to a new branch. So a new branch, new, and we're going to pass it a new position and a new angle. Hopefully I have enough space, otherwise I can just go under it. Okay. So what's going to be the new position? The new position should be the current position. Well, it should be a new, well, so we're going to save this. This will be a p-vector, and this will just be a float. We're going to use the p-vector dot from angle. And so we're going to use this function and pass in the angle that we have. Then what we're going to do is we're going to set the magnitude. So set mag, because this vector that will be created from angle will only be of length 1, I believe, right? And we don't necessarily want the branch to be only like 1 length long, right? So we'll use set mag to set the length of the branch. And this value, we could say random. Let's say for right now, at the beginning, we'll say 5, right? So each branches will be 5 distance away. So that's the whole goal. And then since this would be like, let's say, based on this point, we need to add to this the current position. So this will displace it based on the position, which on this position, which is going to add to this, right? So it's going to basically move this over here. We're going to add x and add y to this point. So that's going to be the new position. The new angle should just be the angle plus or minus some random value, right? So let's say we want the new angle to be I don't know, maybe a quarter pi plus or minus of the initial angle, and randomly selecting that value, but at most a quarter pi away, a quarter pi more or less than the initial angle. So that's going to be the whole thing. And I'm thinking we pass a third argument to create our new branch, which should be like, let's say, because we're going to create the new branch, the next branch, within the constructor of the branch itself. So I'm thinking we will need some kind of exit condition, right? Because otherwise it'll just like do an infinite recursive call, trying to create infinitely many branches. So I'm thinking of passing like I, for example, and starting it at 0, and then we just add 1 to I whenever we create a new branch, and we pass that new I to the next, and so on and so forth. And then we could have like a if I is less than 10, then create the new branch. Otherwise, just don't do it, right? So it'll have a next branch, right? So what we can say is, like, let's say we have a show function in this branch class where if we have a next, then we draw a line from the current position to the next dot position, and then we then call next dot show, right? So recursively we could go right here, right? So it'll do basically whatever it wants, and from one branch to another, it'll be some random angle of difference between the two. So let's get started with this. Let's try to first, let me remove everything that we have here. Awesome. So let's try to first make it for only a single branch, right? So let's create a class called branch. It's going to have a p-vector position. It's going to have an angle. It's going to have a next branch. Let's set this to null by default. And it's going to have, well, I, right? So int I, or iteration, whatever you want. Okay, awesome. So let's create the constructor. So here we're going to receive the position and the angle. And we're going to receive the next I, well, this I. So this the pos should equal. So now let's just do the position, and when we create it, then we'll create with the new one. This dot A is equal to A, and this dot I is equal to I. Awesome. So now this dot branch, this dot next, sorry, is equal to a new branch, which we will pass in the new values, right? So we said to create the p-vector. Well, first we need the new angle, right? Because we need to create the p-vector. Oh, no. We need to create the new position based on the angle that we currently have. Right. So p-vector dot from angle, or we could get that value from like doing cos of x and cos of the angle and sin of the angle as well for x and y respectively, and then multiply those by whatever 5 we said for the magnitude. So multiply it by 5, and then you would get the vector that you want, basically. But we'll use from angle as it's already done for us. So we'll pass the angle, we'll set the magnitude to 5 for right now. Let's say even 20. I want to see them like 5. It's a bit short, right? And then we need to add the current position. Okay. So we have the position done. Now we need the new angle. So the new angle, we said the current angle plus or minus a random angle, which we wanted like a small angle, right? It's going to be plus or minus some small angle. Let's go with a quarter pi, or even quarter pi divided by 2, sorry. Let's go with quarter pi for right now. Okay, and we'll need I plus 1 for next I. And let's do if I is less than, for right now, let's do 50, then create the branch. Okay, all right, that's pretty much it. Let's do void setup. Let's do branch B. This will be the initial branch. So let's do size of 800 or 900 by 900. Let's do a background. Not black, but pretty dark. Let's do B, new branch. And we set the initial position to be a p vector that is at the center of the canvas. So width divided by 2 and height divided by 2. The angle, let's go with a random angle. It doesn't really matter. So let's go random between 0 and 2 pi. And the initial I is 0 by default. Okay, so we've got that set up. Now, let's try, well, let's just see if it runs, right? We shouldn't see anything, but yes, okay, it does. Let's try to create a show function. So this show function, what should it do? It should set the stroke. Let's set it to white for right now. Set, well, the stroke weight, maybe 2 for right now. And then it should do a line, but only, well, it should do show only if next is not null, right? So now let's do the line. So we do a line between this dot pos.x and pos.y and next dot pos.x and next dot pos.y, right? Okay, so if we were to run this, which I'll do, we'll only see one line. I mean, it's pretty hard to see. Oh, I mean, we won't see anything because I haven't called show, right? Now, we'll only see one line, the first branch, right? Just because we're not calling show of the other of the other branches we created. So we'll need to call it, right? So we'll call next.show as well. Right, now we should see all of them, right? Awesome. So we get those branches now. Let's do maybe magnitude 5. So branches are all of length 5, yeah, right? So this makes sense, right? Every time I run this, it'll be pretty much random. Cool. Awesome. So let's do a lot of branch, right? Well, let's do them in draw, right? Let's try to do all of this in the draw loop. Okay, well, okay, there you go. So now we just have infinitely many branches that are getting created. So that's cool. Maybe I want to see like an overlay effect. So maybe I do the, maybe I set some alpha on there. So it's going to be brighter every time it goes over itself. Okay, maybe I want the stroke weight to be back to 1. And maybe I want the length of the line to be a little bit longer now. So maybe like 15. Maybe 15 was too much, maybe 10, right? There we go. So we can see it. That's pretty cool. Let's try let's try adding a bit more randomness into this. So what I'm thinking about randomness, I mean, maybe we don't want the branches all to have the same amount of next branches, right? So so this value here, right now you hard-coded 50, but maybe we want some random value here, right? I'll call it K. Okay. So I'll call it K, and it'll be K here, right? And this dot K, I mean, it's not necessary that we put it in here, but we might want it in the future, so I'll put there. Okay, and then here, whenever we create it, we can say, well, I want some, well, let's convert everything to int. So I want some random value that goes between, let's say, I want how many branches to follow the first one. And maybe between like 10 and 50. Sure, let's try that. So now there is shorter, well, not shorter, but well, shorter path and longer path, right? Okay, cool. What else? What can be random, right? Well, we already have the angle being randomly generated for the next one. Maybe the length of each branches could be random as well, right? And this, I don't think I wanted per, let's say, per branches, but per branch, right? So maybe I want to set the random here. So maybe right now it was at 10, maybe I want the length of the branches to go between 2 and, I don't know, maybe 15. All right, so if I were to do this, and we get branches that are of length 2 and branches that are of length 15, right, between those values. Okay, that's cool. What else? What else could we randomize? I mean, okay, I think that's a good start, I think. Okay, now let's try adding some colors, right? So let's just do, instead of stroke white, let's do, let me get some colors. So my predilection site is this over here, which, let me hide this. Okay, there we go. So just coolers, just choosing any color I want. Let's take this one. All right. So, all right, let's do this. There we go. So now we have one color, right? So we could do, let's try to do a gradient, right? So let's go back to drawing only one line and doing it in here. This will be like our reference line, let's say. So this is fine. Let's get a random value. This will be 0, and let's say by default, well, let's say this, right? Okay, and let's do show 1 and show 2. Sure, it's fine. So show 2 will be our original one, which is just white. Well, no, show 2 will be the one for draw, and show 1 will be basically, or I could just have one show function and pass it the opacity, right? The alpha value. So it'll be an int I, okay, and we'll pass a to the next one. Okay, awesome. So for right now, let's draw it back to white. Okay. B.show, and let's do 255, so no alpha, no transparency. Okay, great. So now let's try to do a gradient, right? So I want a gradient between which colors? Let's say this color and the yellow one. So let's get a function which return a color and does gradient of color C1 and color C2, and or sure, let's start with this. So color C1, color C2, and then we'll pass in our I, which is the iteration we're at, and our K, which is the max iteration. So it should return, what should it return? It should return the lerp between the two colors, so between C1 and C2, at a given amount. And the amount should be between 0 and 1, right? It's going to be a percentage base. So we want to map I, which goes between 0 and K, to 0 and 1, basically. So we'll do gradient. We'll call gradient in here. Call gradient with the first color that we want and the second color that we want. So we set this one and this one. All right. So what's the issue over here? Gradient expects something like int. Let me do color. Oh, yeah, I need to pass I and K. That's right. There we go. Okay, so we did get our gradient. Cool. Now, let's say I wanted multiple colors, right? Let's say I wanted all of those, right? So let's say I wanted this one. Let me do an array of colors, right? So let's call it colors. So color array colors equals an array of colors. Okay, awesome. So this is the first one. Let me just get them real quick. Okay. All right. So which one was it? I lost it. Okay, it was this, right? All right. Okay, great. So now we have our array of color, right? So I want to do a gradient for K, well, for K length, where so let's say between those two, there should be how many iteration, right? Well, there should be K divided by the length of that array of colors, right? So let's remove this. I'll just use the global color. So let's do color C1 equals, we need to figure out where we're at in the K, right? So it's going to be so it'll be I modulus K divided by colors dot length, right? I'm not 100% sure, but sure, why not? Let's pass back C1 and C2, and I just want to see C1. Wait, C2. I just want to console log this value. Well, print, which is C1. Maybe I call it C3 for right now. I mean, it won't be that, but let's just do it for right now. What's the issue here? Missing semicolon. Am I missing semicolon here? Yes, I am. Okay, so what did I get? I have currently 5 values, right? So this is definitely wrong. So I modulus this is to get the index of color, right? So let me think about it. Wait, okay, so this let's do int count per color. Okay, so this is the amount of branches we'll be doing per color. Like for this color will be, and well, for this pair of color we'll be doing this, right? Amount of iteration, right? So this value should be what's get put in here. Well, not true. Well, yeah, okay, wait. Okay, and then we have I. I, it's basically where it's at in K. We could, let me think about this. We could, so I need on a basis of 5, right? Well, of 4. Let me just use map and we can think of the mat afterwards, right? So let me do like int index equals map, and we'll do int map of I, which goes between 0 and k. Oh, wait. Let me think about this. Let me go back to whiteboard. It might be easier for my brain. Okay, great. So we have colors, which is of length 5, right? And we have I, which goes between 0 and k, right? And we have k, which is some number. Let's give it an actual non-fictional value, right? Let's do 10. So when I is equal to 0, the first index, the color we want to select, let's do index, should be equal to 0, right? And when I is equal to 1, let me do them on the same line. Index equals 0. When I is equal to 1, we want index, I'm not sure if it's visible, but hopefully it is. Index is still 0. When I is equal to 2, then we want index equals to 1, right? So how did I do this? We can get this index with map, possibly mapping I, which goes between 0 and k, to 0 and colors.length minus 1. And then that would give us the index. Let's try it. Okay, well, it's been a couple of minutes. I was on the whiteboard. Let me show you what I did. So I did exactly what we said for the index. which got me between 0 and 3 in this case. So there's in total 4 index in the colors array, but that's okay because I wanted up to the third index in this case, well, to the index 3. And so C1 pretty simple, it's just a color at the index. C2 pretty simple as well, just index plus 1, the next color in line. So C1, C2, and then the map is basically index times the amount of I will be doing per color. And the max will be basically the same thing, but the next one, starting at the next one. And then we'll be going between 0 and 1. So that's pretty much what I did for the gradient. Now, where were we? Okay. Yeah, I was just moving this up here. Didn't do anything else. So whenever I run this now, we get the rainbow effect, right? So it was simpler than I thought, actually. Well, using the map, right? I didn't do the math itself. Anyway, it's fine. Okay, now if I were to comment this out and draw a new branch, well, a new like set of branch every time through the loop. And let's do the alpha value as 255 for right now, and we'll see what we can do with this, right? Okay, it seems pretty bad. It looks pretty bad right now. So let me change the alpha to maybe 10. All right, wait, okay, let's try this now. So we won't see much at the beginning, but as time goes on, it'll create itself, right? It'll overwrite on top of itself. Let me do something to speed it up. Maybe we can do this multiple times through draw, right? So for int j, we haven't used j yet, so well, it wouldn't matter. We could use I, but let's just use j. J is less than, let's say we do it 50 times per draw call. J++, okay. All right, so let's see, it should just do it faster. That's pretty cool. So eventually we'll be able to like really see the gradient properly, right? Which was this one over here, where we already see it. The yellow is a bit fade, but that's fine. I mean, we can choose whatever gradient we want, right? We could try it on a white background, maybe would look better, or close to white. I don't like this color. Let's do this. Well, let's do totally white. Let's see. Looks pretty cool as well. So that's the whole sketch. Hopefully you do something creative with it. I'm not sure what it's supposed to represent, but this was fun. So hopefully you have fun with it as well. And let me know what you do with it in the comments below, and give me suggestions and ideas for the next sketch. Thank you. See you in the next one.